5th edition, and the chapter material will be the same. It's pretty much just the problems that they change. So the other reason that I did the 11th rather than the 12th is because hopefully they've already corrected all the mistakes. The 12th edition is kind of a newer set of problems, and a lot of times they'll not have corrected the mistakes on it. So hopefully the older version is more correct. And let's just look at this.
And they have that at the bookstore right now.
You probably do if you have like a grant, you'll have to buy it like from the bookstore. But if not, you may just want to look online.
Okay. And you said the 11th edition would probably be better.
You can, if you want. See, your problems change numbers anyway. So if you want to go, I mean, as far back as the 6th edition, you can get like a 6th edition for like $5.
Okay.
Unfortunately, what these textbooks do is they just change the problems in the back of the book.
Okay.
Yeah. Actually, while we're there, so let me go to the D2L here. And don't tell Mrs. Clutt that I did this. However, I put all the solutions online on your D2L because you can go to Chegg and you can get them anywhere.
Yeah. Oh, Jag.
So on the Brightspace or D2L or whatever, these are my office hours. I actually did update that, so those are definitely not be in my office. But if you need any time after, beyond those hours, just let me know. This should take you to the homework site. So it looks like I need to do something here. It's not letting me sign up for it. So I'll see if there's something else I need to do. I don't know why it's not doing it, but you don't need it today. It'll be up before Wednesday.
Can you help me, because I've had it online and she provided 2 semesters. Can you change your instructor from, because right now it's under Clay.
Is it?
Is there really like changes? Would you just go through that?
Yeah, let's email me and I will email WebAssign and they can switch you into the yeah. So if you got it for like a year, yes, they should be able to switch you into mine. Okay, so where I was heading here. So in the content, everything that I handed out today, actually I can go from there. This is not current, so delete that. I'll update that. But the syllabus, things like that. There's a little grade calculator here, so you can just go. It's just an Excel spreadsheet, and so you can like put in what average your quiz and your homework and your tests are, and then you can figure out what you need on the final exam. This, if you download it, it's just an Excel spreadsheet. I'll give you the final grade here. The formula sheets are here. The PowerPoint slides. Spring 2008 solutions to the test that I gave. Here is where I'm trying to get to. So these are really good documents. Let me just download it. I'll have to say Beer & Johnston does the best solution manuals I've ever seen. So
yeah,
they show So, they'll have the whole entire problem statement here, and they do a really good job at a detailed explanation there. So sometimes it's not exactly how I would have solved it. Especially in statics, they love forced triangles instead of the algebraic solutions. But dynamics, they can't do much with the forced triangles. So did you guys in statics have the solutions manual? Did Mrs. Clett make it available?
No, we basically had to find it.
Yeah, I mean, that's what I figure is you'll find it somewhere, so why not make it easy?
Yeah.
But, do use it to, and at this point, you've made it through all the other ENS classes, so you know how to study. You know that if you're just going to copy it, you're not going to pass the test. So that's that.
Okay.
And then I'll be posting, of course, there's nothing there in the fall 2008 test solutions. Okay. Trying to get to the table of contents here. It does have it. There it is. So what you did in 1520 was kind of a very, a little bit lighter version of what is covered in chapters 11, 12, 13, and 14. Okay, so if you remember in 1510, which was a year ago from a lot of you,
Yeah.
you did the kinematics, which is V is equal to dx dt, remember those? And then, V is equal to V naught plus dt, and V is a constant. Remember those types of equations. So that is the kinematics. And then the kinetics is F equals ma. Okay, so you really remember that. And then we did the work energy impulse momentum. Okay, so here's our three tests. What we call, kinematics, which is like all those formulas. Kinetics, which is basically F equals ma, and then the work energy / impulse momentum. So we're going to do this for a particle, which you've already covered, so we'll cover it fairly quickly. And then we're going to do it for what we call a rigid body. Okay. So sometimes in dynamics classes, they'll do particle kinematics, particle kinetics, particle work energy, and then they'll jump back and they'll do rigid body kinematics, rigid body kinetics, and then rigid body work energy. But I like to let's just eat it, we'll just do it all at once. So we'll do particle and rigid body kinematics, and then we'll move on to both particle and rigid body kinetics, and the same thing for the work energy. Okay, so the difference between, and then actually in 1510, your fourth test was rigid body, all three of those rigid bodies. So this fourth test here was a kind of a brief introduction to the new material that you're going to learn in this particular course. So hello.
Hello.
You must be Roy.
Yes, I am.
Yes, good. Yeah, come on in. I've only handed out one thing pretty much, and just talked the rest of the time. So we'll do like maybe 2 or 3 days, well, maybe 3 days on the particle version of this, and then we will jump over here on chapter 15 for this first test. Then we'll spend about probably close to 2.5, 3 weeks on the rigid body part of it. Okay, because it is more complicated. We have to consider what we added here to F equals ma, for example, is summation of, they called it torques, equals I alpha plus. So, and it's kind of a fun class. It's very math oriented, so I actually like it. So good. Any questions up to this point? let's go ahead and I'll tell you. The other thing that we're doing in this 1510 class is I'm making them view lecture or videos before they come to class, and then they're going to do pre-lectures, and then they're going to come up and teach some very short dynamics problems. So I sat through 3 days of meetings, and I thought, oh, I know what my students are going through, sitting and listening. So we're going to try not to do the PowerPoint so much, but more like interactive type stuff.
That would probably help a lot.
Oh gosh, I was just, by the end of the 3 days, it was pretty bad. Because this is the first day, does anybody want me to print these off? Or do you just want to kind of watch and listen? There's really, we'd have packets. Anybody want me to, I can put them off? No, good. Okay. Oh, 89 pages. So this, you've already covered all of this material, so I'm not going to talk the whole 89 pages through here.
Good.
So this just talks about the introduction and the kinematic relationships and some of the objects that would follow our kinematic equations. So you don't have to memorize the word kinematics, but the first thing that we're going to do is we're going to look at things, and we're not going to know why they are moving in the direction they're moving. We're not going to look at the forces or the masses or the accelerations. That's what the second test will do. Okay, and then particle kinetics means that it's a particular particle. What we do here is we model things as if they were a point. Okay, so particle, remember particle statics, you had things that were like this, and you were only looking at that one point. Okay, and so the same thing here with dynamics, with particle dynamics, you're considering this car to be like a point here. Okay, and so for our free body diagram, for particle dynamics, you would just have a single normal force, and then would have this mg, and then here, then you would maybe have something driving it. And then here, your ma was either in the x direction, may, but we didn't have any rotation. Okay, so that's what gets added for the rigid body, is you start having things rotate. Oh my gosh. So these two slides, what they look at is they develop the relationship that v is equal to dx dt. You guys good with that?
Mm-hmm.
And then when you have an acceleration, then acceleration is the second derivative of position with respect to time or the first derivative of velocity. So let me just go ahead and put these equations up here. So here we have x is the function of time, v is the first derivative of position, acceleration is the first derivative of velocity, and that's pretty much what happens here. So just a little bit about sign here. So positive is to the right. Like if you move to the right, typically you think of it as positive. If you move to the left, you typically think of it as negative. Okay. So here, also with velocity, if it's moving to the right, it's positive, and if it's moving to the left, it's negative. Okay. But here, this could either be positive or negative, and this could be positive or negative. Okay, so you don't know that if you have a positive acceleration, it can either point to the right or it can point to the left. And on these PowerPoint slides, actually this is kind of a good, this is going to be a useful thing here. Okay? So we have the particle at point P, and then it goes to P prime. Okay? So as it goes from P to P prime, the speed, remember speed does not have to do with direction, the speed increases. So the rate at which the velocity increases is to the right, and so therefore the acceleration is positive. Okay, so if we were to do like our delta V over delta X, delta V is positive and delta X is positive, so therefore it's going to be a positive acceleration. Another case would be, let's see what the second case is, would be that it's moving to the left and the speed is decreasing. Okay, so again here we have our delta V over delta X, so it's slowing down, so our delta V is negative, and our delta X is negative, so therefore it's a positive velocity. Okay? So if you were to draw the acceleration, even though the velocity is to the left, the acceleration would be to the right. Okay? It is accelerating to the right because it is slowing down to the left. So if something's moving to the right and you get a negative acceleration and you think it's wrong because the acceleration is to the left, it could be right. So don't think that acceleration has to be positive if it's moving to the right and negative if it's moving to the left. It can be either. And so this one is, again, kind of your more obvious one. Positive delta X, but it's slowing down, so therefore it's going to be a negative acceleration. And then finally, speeding up to the left is a negative acceleration. So your speed is positive, and your change in X is negative, so negative acceleration. Let's just review and see if they have a PowerPoint slide. So this is supposed to get you guys involved here. What is true about the kinematics of a particle? What do you think? The velocity of a particle